In this video lesson, we're going to be looking at index laws 3 and 4, which both involve raising two powers. So you've got your learning goals there, but we want to get straight into it here. And we're going to look firstly at index law 3. So index law 3 basically states that any value to the power of 0 equals 1. So a to the power of 0 equals 1 is a formula. And that basically means that any value except for 0 raised to 0 equals 1. Okay, get a little bit confusing, but it's quite a simple index law once we understand it. So for example, 4 to the power of 0 equals 1. In this example, we've got numbers in the brackets, so we have in brackets 73xy to the power of 0 equals 1. So any value to the power of 0 will equal 1. So it could be 15, 2,774 to the power of 0 will always equal 1. And to understand that, if we want to understand why that is the case, we can sort of apply a bit of index law 2 and also some understanding fractions of why that is the case. So here I have an expression. I have 8 to the power of 6 divided over 8 to the power of 6. And we know that index law 2, that basically just says 8 of, so the powers are subtracted. So it's 6 minus 6. So basically these just cancel each other out. And what we are left with is 8 over 8. And then when we know from fractions or our division, 8 divided by 8 will always equal 1. So it's kind of that understanding of why that is the case. We want it to be sort of consistent throughout maths. But basically, again, a to the power of 0 equals 1. Now that you know that, we can do some different examples. So let's look at these two here. And we've got a range of different approaches here. So we firstly have 10 to the power of 0 plus 5 to the power of 0. This is basically saying 1 plus 1. Okay, so here, this is going to equal 1, and we have 5 to the power of 0 equals 1. So our answer in this case is 2. The next example, we have in brackets 4x to the power of 0 plus 8xy to the power of 0. Now, because each of these are within the brackets, again, this is just saying simply 1 plus 1. So here, 0 is applied to all them within the brackets, which makes it 1. And here the 0 is applied to everything in the brackets as well, which makes 1. So again, we have the answer of 2. Now here we have the exact same sort of expression, except the brackets are removed. It'll be a good idea to show you how we can apply that. So in this part, we have 4x0 multiplied by 8xy0. And if we expanded it, remember from previous videos, there's basically a multiplication symbol in between each of these. Okay, so really what we have is 4 times x over 0 will be 1. So I'll fix that up. So 4 times 1, and I'll put brackets around that because that's on that side, times 8 times x times, and we've got y0, which that's going to be 1 times 1. So now I have my expanded expression, and now I can just simply apply everything else from here. So 4 times 1 equals 4 times 8 equals 32. So we've got 4 times 8. I'll bring the 1 closer so we get a good example. Times 1 times x. I'll put my numbers next to each other. So I now have 4 times 8 times 1, which equals 32x. Okay, so you can see in that example, good examples there to show the difference with brackets and how that is applied. But again, the same principle for index law 3, is the pronumeral to the power of 0 will always equal 1. Now let's look at index law 4, and this one can get a little bit more tricky, and it's kind of linked also to index law 1. And index law 4 states that a to the power of m in brackets to the power of n is the same as saying a to the power of n times n. So now in index law 1, we had a plus m, m plus n. When we have a power to a power, we're actually multiplying those together. So it states that a power of a power can be simplified by multiplying the indices. So in this example, we have x to the power of 2, which is multiplied by 5. Basically means we multiply these two indices together. 2 times 5 equals 10, which is why we have x over 10. Now another key thing that you need to make sure you do is that you want to try and expanding. So expressions involving powers can be expanded. So when we have 3x in brackets to the n, we're basically applying our distributive law. So the power of 4 is applied to both of those in there, and that gets expanded to 3 to the power of 4 to x to the power of 4. Now let's apply that quite simply in these next examples. We have 2 to the power of 3 multiplied by the power of 5. So again, we're just applying here. So that makes 2 to the power of 3 times 5, which equals 2 to the power of 15. And in this case, we have numbers within the brackets, and we want to, as I said before, apply our distributive law. So basically, this is saying 5 to the power of 2 times x to the power of 3 times 2, which gives us 5 to the power of 2 times x times x6, and now I can just simply combine these, which means 5 to x6. Okay, so I've simplified that by again expanding those brackets and then simplifying from there. Now it's applied again to a little bit more elaborate part from here. So we have u to the power of 2 to the power of 4 times 7u to the power of 3 to the power of 2. So I'm going to start this part, which will be u 2 times 4 multiplied by 2 to the power of 7 u times u 3 times 2. So I'll convert all these first. So basically what I have is u8 times 7 squared times u6. Okay, now notice that I've got two like terms here of u with a base number of u. So again, what we'll do there is that I'm going to need to apply index law 1, okay, because we know from previous videos that any power multiplied by another power means we add. Okay, so a m plus n. So these two here, I'm going to add the indices. So that gives us 7 2 multiplied by 8 plus 6 equals 14. U14. So index law 3, again, any power to 0 equals 1, so any base to the power of 0 equals 1. And index law 4, again, we're using the multiplication. So am to the power of n equals a to the power of mn. Okay, if you have any questions, make sure you bring them into our lesson and we can go further into detail about them. Thanks, guys.